The Earth may seem massive and inspiring, but it's only a speck in the vastness of the cosmos. Technology has enabled us to explore this great unknown, sending rockets and satellites into space to uncover the mysteries that lie beyond our own planet. Our curiosity drives us ever onward, with each new discovery inspiring us with fresh wonders to uncover. We long to unlock the secrets of the universe and explore its infinite depths. How do we do that? With Voyager, which sends us valuable information to process. However, things haven't always been so seamless. For the past couple of months, we had no contact with Voyager, and after months of silence, it's back with an unexpected discovery. Join us as we delve into what happened and what this discovery means for the future of humanity. But before we get into that, let's dive into the Voyager mission as a whole, how it all began. The launch of Voyager 1 and Voyager 2 was an event that forever changed the course of history. On August 20, 1977, Voyager 2 launched into space, its mission to explore the vast reaches of our solar system. This was only the start. Shortly after it left Earth, NASA made history by capturing a picture of both the Moon and Earth in one frame. The primary purpose of the Voyager mission was to explore the outer planets of our solar system, but it also had a second goal, sending back data about the stars and interstellar environment beyond. To accomplish this, the spacecraft had been equipped with sophisticated instruments to monitor its surroundings as it traveled through space. These instruments allowed us to collect information on magnetic fields, particle densities, radiation levels, and even the properties of interstellar clouds. Voyager was also equipped with a unique communication system to send data back to us from its travels through deep space. This communication system was critical for understanding what Voyager was seeing as it passed by planets, moons, and stars alike. Voyager 1 followed its sibling closely, launching on September 18, 1977. With both spacecraft on their way to explore and document our corner of the universe, a journey like no other began, one full of discoveries that would astound us. From its launch onward, the mission promised to be truly extraordinary. It was a journey to uncover the secrets of our solar system and delve deeper into what it had to offer. The future looked bright for Voyager and its mission ahead. No one could have expected the abundance of information this project would bring us in the decades that followed. The mission had been perfectly plotted out. Despite the common assumption that our solar system is round, it is not. Instead, all of the planets orbit in an irregular oval, and there are only certain times when they align in a way that makes space travel efficient and effective. August and September 1977 was one such window, a rare opportunity where all the planets along Voyager's journey were in its path. This meant that it wouldn't need to deviate much from its route, making the mission both possible and successful. It was truly a remarkable moment in history. The stars and planets seemed close enough to touch as the $865 million probes left Earth, heading out into deep space. In a single year, they had made it all the way to Jupiter, defying expectations and sending back an astonishing 4,000 images of the gas giant up close. 2 new moons and an additional ring were also discovered, leaving scientists in awe. It was clear that the mission had been incredibly successful and that all the effort put into preparing these probes was worth it. Every moment, they sent back more information about our solar system, small glimpses of things we were only beginning to understand. With each new discovery, things became even crazier. Who knew what they would find next? The possibilities were infinite. One of the most notable times we heard back from the Voyagers was when Voyager 1 captured a breathtaking image of Earth from 11.7 million kilometers away. This was the very first time a photograph of both Earth and the Moon had been taken from such a distance. This was incredible because it gave us true insight into how the Moon and Earth come together as one unit, something we had just been theorizing about until that point. To think that this box of wires and metal hurtling through space at immense speed was able to take such an incredible photo from over 11 million kilometers away is simply mind-blowing. It's remarkable that we as humans have been able to create something so amazing and advanced that can achieve this. On March 5, 1979, Voyager 1 took its first picture of Jupiter from 57.6 million kilometers away, an amazing feat in itself, but this was just the beginning. On March 9, 1979, volcanism was discovered on the Galilean moon. After analyzing a picture captured by the probe, it became one of the first times it was even thought possible for such phenomena to occur. This was around the time we first lost contact with Voyager 1, a very scary moment for everyone at NASA and for the world. After all the time, resources, and dedication put into this mission to explore our solar system, it was nerve-wracking that something could have gone wrong. It was something that hadn't ever happened before. Let's just say that the team at NASA worked day and night to regain the connection. While there was a period of uncertainty, they eventually managed to establish contact and get things back in order. Just when we thought things couldn't get crazier, on November 11, 1980, Voyager 1 had its first flyby of Titan, Saturn's largest moon and the second largest in our solar system. The data and images sent back to Earth showed us a world far more complex than we had ever imagined. One of the most significant discoveries from this encounter was that Titan is not as large as originally thought. Scientists had previously estimated Titan's size to be between 6,000 to 6,500 kilometers in diameter, but Voyager 1 showed us that it was actually only 5,150 kilometers across, about 25% smaller than originally predicted. Voyager 1 also revealed a mysterious atmosphere on Titan that was 10 times thicker than Earth's, containing nitrogen and a variety of organic compounds, hinting at the possibility of life on Titan. The probe also found that Titan had an abundance of methane lakes and seas, making it one of the most Earth-like objects in our solar system. All in all, Voyager 1's flyby of Titan was a monumental success. It showed us that there is still so much to explore and discover, even in our own solar system. Eventually, the spacecraft would also reveal the true largest moon in the solar system. Voyager 1's flyby of Ganymede on June 5, 1979, was a significant moment in our understanding of this moon and the solar system. Before the flyby, we had very little information about Ganymede and what it looked like. Its size was also unclear, with estimates ranging from 3,000 to 5,000 kilometers in diameter. Voyager's close-up images of Ganymede revealed an icy surface with extensive crater terrain and strikingly showed that its size was much larger than previously thought. In fact, it is the largest moon in our solar system at 5,268 kilometers in diameter, just slightly larger than Titan. The pictures taken by Voyager 1 also revealed a unique geological feature called groove terrain, which consists of narrow lines and ridges that run parallel to each other on the moon's icy surface. Scientists believe this was caused by a process called diapirism, where warmer material from the interior of Ganymede rises and breaks through the cold, brittle ice crust. By this point, it was clear that the billions invested in this project weren't for nothing. They were bringing in unheard-of information one step at a time. While the initial idea was just to have the Voyagers check out our solar system, it was clear that both of them were more than capable of venturing into the beyond and still sending us information. Thus, the new plan was to let them continue into interstellar space should they make it there and finally get a look at what's really beyond our solar system. On November 12, 1980, Voyager 1 made its closest approach to Saturn, coming within 121,000 kilometers of the planet's cloud tops. During this encounter, the probe revealed to us an incredible world filled with fascinating features like colorful clouds, swirling storms and icy rings that stretch for thousands of kilometers. Nearly a year later, on August 25, 1981, Voyager 2 followed in its companion's wake. On January 24, 1986, Voyager 2 made its closest approach to Uranus. This historic encounter revealed an icy world filled with remarkable features like blue-green clouds and a complex system of narrow rings. The probe also found that Uranus had 11 distinct moons: Miranda, Ariel, Umbriel, Titania, Oberon, Cordelia, Puck, Bianca, Cressida, Desdemona, and Juliet. Voyager 2 also identified two previously unknown rings, the Epsilon and Delta rings, composed of small particles ranging from tiny dust grains to larger debris. The data and images sent back from this encounter revealed a world far different from what we had imagined. Scientists discovered that Uranus had the coldest atmosphere in our solar system, with temperatures averaging around -224 degrees Celsius. We also learned that Uranus has an enormous magnetic field, which is oddly tilted and aligned differently than the planet's rotation axis. On February 14, 1990, Voyager 1 snapped the iconic family portrait of our solar system. This image is made up of 60 individual frames that have been stitched together to create a single mosaic. It shows 6 planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn, and their moons with the Sun as a tiny dot. This image, the first of its kind, gave us our first glimpse of our solar system from the outside looking in. The photograph became a historic milestone in space exploration because it showed us that we are just one small part of an expansive universe. After this, the craft would move out of range for taking any more images, and thus the Voyager mission would be all about making observations of what the Voyager crafts passed as they made their way toward interstellar space. One of the coolest parts about this phase of the Voyager program was the Golden Record. Every so often we hear about how aliens might contact us someday, but what if we reach them first? That's what the Golden Record was all about. NASA made sure to include something they referred to as the Voyager Golden Record aboard both of the spacecraft. These records contain images and sounds from Earth as a way of introducing humanity to any extraterrestrial beings that might encounter Voyager in the future. They also contain music from various cultures and time periods, including pieces by Beethoven, Bach, and Chuck Berry, as well as traditional folk music from all over the world. There's even a recording of human voices in 55 languages with greetings such as hello, shalom, namaste, and salam. These records were placed on Voyager with the hope that one day an intelligent alien race might find them and learn about us. To make sure the record lasts for as long as possible, it was made out of gold-plated copper, which is much more resistant to wear and corrosion than other materials. The golden record was a brilliant addition to the Voyager mission because it not only serves as a message from humanity but also acts as a time capsule that will last for billions of years, long after we are gone. In fact, if humanity were to disappear tomorrow, the golden record would likely be the only trace of our existence left behind. It's amazing to think about how something we made could last so long and potentially be discovered by other civilizations in the distant future. It's easy to assume that by this point the Voyager program had peaked, but what happened next is just incredible. When the Voyager probes hit the heliosphere, the information became even more valuable than ever. We had no idea that something like the heliosphere even existed, but the probes helped us uncover it. The heliosphere is a massive bubble of charged particles that surrounds our solar system, and it acts as a shield protecting us from the harmful cosmic rays of interstellar space. The Voyager probes were able to measure the intensity of these particles as they crossed through this region.